Welcome, CEDU to 2400 Design Interacting 2 class students. So this is week 6 pre-class lesson. So this week's topic is making models. So last week we learned about sketching, how we can draw a sketch on Fusion 360. So since from this week we're gonna use the sketch to make 3D features. That is called the modeling. So this is this week's lesson objectives. So let's take a look at the objectives. So after this class, you'll be able to understand the difference between parametric and direct modeling. So there are big differences. So I'm going to explain this one a little bit in the pre-class activity, pre-class in this pre-class lesson. And after that, in class, I also practice the two different practices in the in-class lessons. Also, you are use appropriate types of modeling method to accomplish your desired 3D modeling. And then there are some techniques that we are building this week. So extrude, sweep, revolve, and loft. So these are very useful tools to draw 3D features. And then after that, we are finishing two modeling assignments. So that is using construction tools. So let's take a look at this pre-class lesson. So this is the uh, review of week 5. Last week, we learned about constraint and construct in Sketch Fusion 360. So this was practice 3 assignment. I canceled because we don't have enough time to finish this one. So let's take a look at this example together, and we'll see how geometry and constraint can be used to draw this 3D feature. Okay, so I provided you with these step-by-step procedures. So let's take a look at this briefly about the steps. So first step is to draw this one. We need to draw this geometry. So I'm going to use lines to draw this object, right? And then this is a numerical numbers, 500 millimeter, 100 millimeter, and then 45 degree. And you see some symbols right here and that one. So that represent, let's take this one. So this symbol, so that looks like this. So you see this one and then this one. So that means this length of this one is equal to this one, right? So that's why they use this symbol, right? This one and then this one. It's the same. So this length and this length is the same, okay? And then also you see these constrained symbols. So these also represent that two lines are parallel. So these are parallel and these are also parallel. So we are going to apply parallel constraint to these lines. And then next step is adding two circles and then adding this fillet. So with 100 all value, radius value. And the next step is we are going to align these circles with this construct geometry and then make 3D feature. So let's go to the Fusion 360. So this is a new file. So you can start with the blank file and then you can click this button, create new sketch, click, and then we are going to select XY plane. So if you hover your mouse, you will see different planes. So click XY plane, and let's take a look at the your 3D. I'm sorry, sketch the sketch lines. So I'm going to draw 500 millimeter this line, and then I'm going to extend this line and then repeat the other lines. Okay. So let's just start from the center and then draw 500. So I can type 500. Okay. And then next, I'm going to draw this one. So it's 45 degree. So if you move your mouse, if you see the reference line, so 45 degree and also 90 degree, and then the side was 100, okay? And then I'm going to continue drawing the lines. So that is, and then let me draw this one, and let's finish this one, okay? Okay, let's compare with this, our sketch, our uh, draft. So I did 500 millimeter and then 45 degree. Okay, so see, so there was 45 degree. So to make sure we have 45 degree, I will draw a line, and that is line, but that does not appear to this uh, my sketch. So I'm going to make this line to construct line. So construction line. That means that is a guiding line, not actual line. And then to see its degree, so I'm going to add sketch dimension, click, and then click this one, and then extend to this one. So it says 45 degree. So if you want to change the degree like 50 and type, the automatically change the actual angle. But in this example, we're using 45 degree, okay? And then the next step is this line is same with this line, the length of this line is same with this one. So I'm going to use constraints. So click an equal constraint, and then click the first one, click, and then with the second one, right? And then that changes this size, so right? So let's take a look at this actual dimension of this one. So I select sketch dimension, and then select the line, and then extend your mouse. That shows the um, the length, right? So the warning message was that this line was already applied a constraint that was equal constraint. So that's why the message popped up. So if I change this line, so length, like 120, the automatic apply to this one. So this is because we used applied constraint, equal constraint to this and this line. So I'm going to make back to 100. Okay, so we are ready. So let's take a look at the first, our sketch. All right. Erase all, we delete all the lines. Okay. All right, so this looks like same as my sketch. So I'm going to move to next step. So next step is adding two circles at the end of each rectangle, and then adding fillet, applying fillet to this edge of these two objects, two geometry. Technically one geometry, but I explained that it seems like have two, this rectangle and this rectangle. Anyway, so to make a circle, we can use um, the circle geometry. But to a more accurate circle, I'm going to select the 3-point circle. Let's see what happens. Maybe two circle, right? And yeah, two circle is much better. So I click first starting point and end point. So I click the 2 points of the end of the geometry and click that draw a circle, right? So I'm going to add one more circle here. So I'm going to click mouse right to find quick menu, and then you can click repeat 2-point circle, or you can select a 2-point circle from this menu. So in this example, I'm click this and then drawing another circle here. All right. So we draw to circle, and then I'm going to trim out on the other lines that we are not using. So this line we are not using, this one and this one and that one. So that all right. So we finished step 2, but not yet. So we added the 2 lines, but we need to apply fillet to here and here. So let's go back to our sketch. Yep. And I'm going to apply fillet on his line and this line. So to use the fillet, I'm going to select the modify menu and find the fillet, right? Click and you see the mouse and then change the mouse with a small icon. So that's fillet. So we are ready to use fillet. So I'm going to select the edge line, clicking, and then it shows 100 millimeter as default. You can change by moving the mouse. But this example, we're using 100 millimeter radius fillet. I applied the first fillet and then second fillet. Also, I'm repeating fillet and click, finding that one. But in the second line, so that automatically pop up the fillet feature. So in this case, you can select 2 lines that meeting the fillet, right? And then click. So I'm going to repeat this example. So I select the fillet, and then I'm going to apply fillet this line and between this line. So I can click this one and then this line together, and then that's applied fillet, right? Click answer, return, and let's see. Yes, so we finished step 3, and then the next step is step 3. So in the step 3, I'm going to add 1, 2, 3, 4, 5 circles, and then circles diameter is 50. And then circles are aligned with this guiding center line, right? So to do this, to draw this one, I'm going to draw a line, but this line is not actual geometry line. That should be the line type is construction line or center line. So let me draw a line first. This one, then move to this at the end of this one. Okay. All right. So this is actual geometry. So I'm going to change these lines to center line by clicking the line types and then repeating the another line with the making center line. All right. So that seems like that line is already center line. Okay. And then I'm going to draw circles. So first circle is placed here, the center of this end line. So click and drawing circle. So the diameter was 100, out 50, and type 50, and draw one. I draw one circle, and then repeat the diameter circle here, 50, and then adding circle 50. So, and then I need to draw 2 circles in here and then here. So that is the 2 circles should be center of this line, of this one and this line. So midpoint of this line. So I'm going to draw a circle. So randomly draw any position. So 50, and then circle. And if you move your mouse, you can see a triangle symbol. So I'm moving my mouse, and certain point that shows this triangle. That means this point, this position is center of this line. All right. So in this example, I'm not going to draw a line on a circle and in this center line. I I will explain why later. So it's 50. And then to make sure this circle is placed on the midpoint of this line, I'm going to use a constraint. So I midpoint and then click this object with this. I'm going to again. So click midpoint and select this line with the center of this circle. Okay. I see what happened. So okay, let me see. I'm going to draw a midpoint, and let's do this first. So this circle and this one. So that is the center of this one, center of this line, this circle. And then I'm going to draw select this line and this geometry. So that changes this geometry as well. So in this case, so we can fix this line. So when I applied midpoint, that automatically use this line, that change this line, right? So I don't want to move this line, this one. So I'm going to lock this line using fix function. So fix, and this one I'm also going to fix these lines. These are fixed. And then I'm going to use midpoint, this one and this line, right? And only this object was influenced by midpoint, right? Do you see the differences? So in the before, I applied midpoint without fixing these line. These line automatically moved because to make this circle is the center of this line. So, but after that, I fixed these circles and these lines, and I applied midpoint with this one. So only changed this line and this circle, right? So I think we almost done the drawing the object. So we apply this the midpoint and aligned with the line. The circle is aligned with this line, along with this line. And then the last step is making this actual 3D object. So let's go to the sketch and finish sketch because I finished. And then I'm going to extrude this object. So let's click this one object and then extrude 50. Let's do 50. All right, so we finished. We finished drawing this object, right? So yes, this was uh, the last assignment I gave you last week. I canceled, but that will be your pre-class assignment, first assignment. Okay. All right. So the next step is parametric and direct modeling. So I will explain this one, details about this one in my in-class lesson. So there are two types of modeling method in Fusion 360 or on all the CAD software, parametric and direct modeling. So there are lots of arguments between the users or developers which modeling method is the best, but still ongoing debate. So but Fusion 360 adopted two modeling methods, parametric and direct modeling, the both. So let's use this example to explain the parametric and direct modeling. So I'm going to draw this object with the sketch. So I'm going to enter the number. This number will be parameter. So that means I'm drawing this object using parametric modeling. Okay, so we can use this geometry. So work the parametric modeling is the best when the project needs exact dimensions, like this example. So we can put the 50 or 50, the exact dimensions. So, and then all actions are captured in the timeline. And then you can, anytime you can change any operations, such as size, or you can change geometries, also you can change the parameters, relationships. So let's quickly take a look at this example in Fusion 360. Okay, so I draw that example already. This one. Okay, so this is not actually the same as this object, but this is the object I drew using parametric modeling. So there's a shapes, so you can see it's a sketch. So I'm going to open Sketch by Edit Sketch. So you see this the numbers. So if I change the size in this my sketch, for example, if I change this line by putting number like 60, right? I changed this only this line on sketch. But if I finish the sketch, you will see the change of the size in the 3D picture, 3D object, right? Because we draw this object using parametric modeling method. Let me show you another example. So what if I change this number, like 30, right? So, and then I'm finish sketch and look at the 3D object. So that automatically changes this diameter of this circle because I changed the circle in my sketch. So that's the parametric modeling. Okay. So yeah, there's a many relationship as well by object. So we can apply constraints. And what about direct modeling? So direct modeling is best for conceptual thinking, conceptual drawing. So I heard that many of you compare Fusion 360 with Tinkercad, but if you have drawn any object in Tinkercad, you have realized that Tinkercad doesn't use parametric modeling. Tinkercad is the direct modeling, or a example of direct modeling software. So that works for best for conceptual thinking, or no association between sketch and bodies, no timeline, no relationships. So let me show you a timeline on Fusion 360. So this is parametric modeling. So you see this bottom menu. This is timeline menu. So that means your all operations or drawings are recorded with the timeline. So if I change the timeline and then the change show the different object by time, right? Or you can play your drawing. Oh, it was so fast, so yeah, it was too fast to see. But you can see, yep, this shows how I changed. So this is timeline. But direct modeling doesn't provide any timeline. So in this example, you can change your object to direct modeling by clicking here and then mouse right click, and that will show you a menu, pop-up menu. And at the end of this menu, you can find do not capture design history. So this is the menu. You can convert your drawing into direct modeling. So let's click this menu. And there's a warning message, the timeline and all design history will be removed. That means this modeling will be converted into direct modeling. So you can click continue, and you see the timeline menu has disappeared, and then you can more easily change the geometry. So as an example, in 3D picture, you can change your side by press pull, right, this side, and then also you can change the side by changing your menu, right? I'm going to change like 10. Yes, it will change. Also, you can change this height, right, by clicking, but um, only this change by this side, right? Or we can extrude objects by changing, right? Because we are using the direct modeling. So let's go back to, I'm going to undo. So I did undo and then I move back to parametric modeling. So you can come back to parametric modeling by undo by clicking this one. So this is parametric modeling. So I'm going to show you one big difference between parametric and direct modeling. So I click extrude and I'm going to extrude this one. So you see, let me try this another way. Go back to, yep, I see. So yeah, it's just ignore. So there was some relations between this one, but only apply this one. So yeah, anyway, this is the example of parametric and direct modeling. So, okay, so direct modeling is best for conceptual thinking, I explained. And I'll give you this assignment as your second assignment. So, and then we can practice more in the class. So let's prepare this practice, this sketch. So I'm providing these lines. So in sketch, and you will need to draw this object, 3D picture using fillet. So I'm providing this size and 30 millimeter and 20 millimeter, and the R was 7.5. Then yep. So I created this video, the guiding video in this YouTube video. So you can take a look at this video on this YouTube site, and you will see my tutorial to draw this object. All right, so thank you for listening to my pre-class lessons. I will meet at yes, at 5 p.m. this Wednesday. All right, thank you.